Welcome to Hy-Pro's Factory Side Chat podcast. We welcome two of our industry's thought leaders in today's episode. We have Peter Dufresne, CEO of EPT Clean Oil, and of Hy-Pro Filtration, we have Aaron Hoeg, General Manager, Hy-Pro Donaldson Industrial Hydraulics. Today's podcast is being recorded remotely. Guys, if you don't mind, if you could introduce yourself, that'd be great.
Sure, Scott. So this is Aaron, and while I've been with Hy-Pro since 1993 officially, my dad was the founder in 1986, so I was also around the shop back then as a youngster. I've been with the company ever since and seen some remarkable industry growth and also some remarkable growth in our company with our team, our products, our technology, and I'm really grateful for how far we've come in a relatively short amount of time.
Hi, my name is Peter Dufresne, and we have a similar story to Aaron, actually, just completely from a different part of the world. We started EPT in 1994. My dad was the founder and solved some technical issues in the industry that became industry standard methodology to solve. And he started getting calls, so he would call me, and one thing led to another, and then we started the company. And I never expected to be doing this for 30 years, but really, as very similar to Hy-Pro, by bringing something new and a new approach to the world, it just caught on, and users just came to us. And what's interesting about the EPT side of the equation here is it's completely the opposite side of particulate removal. Hy-Pro has done an incredible job bringing quality filtration to the world, and it was a story. As soon as I heard it, it was like, I need that. That's different. That's just what the world needs. EPT is working on the dissolved side of the equation, so it's been a really interesting journey to get to here. I'm happy to be here today, and really grateful for being in this position. Thank you.
Okay, thanks guys. Really appreciate the introductions. Today we're discussing Hy-Pro and EPT's joint marketing product, the SVR, and discussing varnish. How did you guys get to come across and meet each other, and how did the partnership begin?
Well, let me answer that question, and I'd be curious to see Aaron's response. But I met Aaron's dad in Houston at a NORIA conference, and I had just taken some sales training, and they told me that at these conferences, make sure you sit at tables at lunch with people you don't know. So it's exactly what I did. And lo and behold, I sat down with Larry Hoeg, and we had a great conversation. And it wasn't even about work. It was just about life. And when we actually realized where each of us were working, we'd heard of each other, and that led to things. That's our starting point with Hy-Pro.
Yeah, I can echo that too, Peter. I remember that story when he came back and said, "Hey, these guys with EPT are doing something different, and they sound a lot like us. They're some of the things they're doing, there's no textbook for, and there's some pioneering work going on, just like what we were doing with the DFE, and I think we ought to be working together." We started to supply filters to EPT Clean Oil, and then sometime down the road, when things took a turn, then the partnership got a lot closer.
Thanks, guys. That's a great story. So just to review, we're going to be talking about the Hy-Pro and EPT's jointly marketed product, the SVR, and discussing varnish. More importantly, shifting the mindset from simply removing varnish to evaluating the chemistry of the oil and addressing varnish issues more proactively. When the strategy is employed, turbine oil theoretically can last the life of the turbine. It's a long time, saves a lot of money. So let's get into this. I'll start with you, Peter. Do you think there has been an industry shift on how to handle varnish and oxidation byproducts within the time that you've been at EPT?
There sure has. Back in 1992, 1993, it wasn't even called lubricant varnish. they were just called lubricant deposits. So we were actually working on solving the problem of lubricant deposits before varnish was even coined. So yeah, there has been a great awareness over the years. And in 2005, actually, GE was the first company to issue a technical information letter, or a TIL, that said this is becoming an issue in industry. And although we do not know the cause of varnish, these electrostatic machines are offering some mitigation support. So that was the 2005, and then 2009 we fully understood the cause of varnish, and the solution really had nothing to do with electrostatics. But we're living in this moment now where the industry is somewhat confused, and doing things incorrectly, or could be doing things in a better way. So there's a great deal of confusion in the industry right now. So I'd say there's been enlightenment, advancement, but depending where you go and who you're talking to, there's a lot of confusion as well.
Yes, I agree with you. A lot of confusion. Aaron, would you like to add to that as far as the industry shift and how they address varnish?
Well, I remember the progression of this when our field sales team was visiting power plants to talk about main turbine lube and hydraulic control filters. And the word kept coming back, hey, they don't want to talk about filters. They've got this deposits, varnish, you've got these peaking gas-fired turbines that fail to start when they're called to produce power. And they don't want to talk about filtration. They want to solve this varnish issue. So, and we were working with EPT Clean Oil, starting to work with them at that time. And, I think the stars aligned, and we embarked on this journey that we've been on of two independent companies putting our strengths to work, where we both have strengths and things that we're really good at to bring the real solutions forward. So, at that time, it was all about preventing a fail to start, helping a turbine successfully run. And, over the last several years, we see this shift, I would say very much driven by our collective to educate people and move the discussion forward to, once you can demonstrate that you can protect the turbine from fail to start or a unit trip, the discussion becomes as much about oil life extension, lubricant chemistry management, and really extending the life of turbine oils to the life of the turbine. And it can even become a sustainability discussion. So yeah, it's really changed over the years.
Yes, I agree, and I think that's been a positive. Peter, back to you. I want to ask this question to start with. What's the predominant response you hear from maintenance and reliability people now, and as compared to maybe 15 years ago, as far as reactive to proactive, and even including being mindful of changing the resin canisters in a timely manner, looking at the lab reports and understanding them? What's your opinion on the change and how that's viewed?
Well, I think the first part of your question there is really the key part, and there's a lack of awareness, and engineering school doesn't teach people about lubricant chemistry or oil analysis. So depending on our starting point with a new user, it could be like they know nothing, or they're actually very sophisticated. So we're seeing pockets of excellence and pockets of really just becoming aware. So, to step back from that just for a second, I'd say you could sort of classify people into a couple different categories. There's those that are doing nothing. There's those that are doing the wrong thing. And there's those that have implemented a solution that's extremely effective, and these users are operating at a completely different paradigm with incredible environmental and economic savings. So, I sort of get frustrated. It was like, well, why isn't everybody there? It just seems logical that everybody would be there. But we see so many people in the do nothing or doing the wrong thing phase that it's a challenge to overcome, and it really has to go back to education.
Yes, I agree. And when we first got started with this education was paramount. Aaron, I want to ask you that as well. Do you see, it seems like there's more and more people that are more aware of varnish, but like Peter was saying, we do come across pockets where this is still very new. So there's still an education process involved.
You can definitely tell when you're operating with, or when you're working with an operator who's had an issue versus one who hasn't. People who have experienced a problem, and even better, people who have adopted a total solution and are operating trouble-free. Um, completely different worlds. And the education is every day, and it's an ongoing thing. And I agree, with Peter that it can be frustrating when you encounter users that are not aware of what's happening, and we have such a complete solution to help. So, but it's an education process, just like anything else. And I think that's some of the most important work that we do is the training, especially on oil analysis, and but being able to simplify what can be taken as very complex and deliver that message to people is really a powerful thing. And I think that's one of our biggest roles in lubricant chemistry management.
Yeah, we see such, just to add on to that point, Aaron, we see such a diverse starting point within companies, and there's really companies that are moving at light speed, best in class, highly optimized, lowest cost states, highest reliability state, and then we see the inverse of that too. And I think there's a number of reasons contributing to that, but it really starts with the foundational pieces there. And working with companies that can teach you those foundational pieces are really essential to transitioning to that new paradigm, right, where you are in lowest cost state, highest reliability state.
When we talk about a complete solution, and we're talking about the SVR in particular, we also have the high efficiency Hy-Pro Filtration products on there, including VTO media as needed. Aaron, if you could talk about a little bit about the quality that and what we're trying to address there. We have particulate management. We have sample port placement of the correct location on the SVR. So this is much more than just oxidation byproduct mitigation and control.
Yeah, I think the best way to describe the solution is it's customer centric. So we've put every detail into the design, the operation, the quality, the technology that's on board. When I look at the SVR, I think, if I owned a turbine, that's the one that I would want, because everything that goes into that design makes it the one that, I know my fluid is always going to be in spec as long as I'm doing my part, as long as I'm sampling and testing and changing filters that need to be changed on time. It's trouble-free. And, we've encountered some customers who take that approach, and you can tell they have an air of peace of mind about their lube oil, and they've got 99 problems, and their lube oil is not one. So that when I think about SVR, that's what comes to mind. It's not undersized, it's right-sized, it's industrial quality. The technology on board is the best, and so to me, total customer-centric solution.
Let me just add on to that, because I agree 1,000,000% with what you just said, but the problem with lubricant contamination is that it exists in multiple forms. So you got to ask yourself, before you deploy solutions and spend maintenance dollars, what form physically is the contamination that I'm trying to remove in? And I see this every day. Gas turbines or steam turbines are running at elevated temperatures. and at elevated temperatures, the root cause of failure is dissolved. So is your maintenance strategy doing anything to address the dissolved impurities, the waste molecules that shouldn't be in the oil in the first place, right? And inevitably the answer to that question is no, or even worse, I've implemented a solution that only deals with insoluble or solid material, and at operating temperature that machine's doing nothing. So I see this mismatch between the form that contamination is in and what machines or maintenance strategies are being used to remove that. The beautiful part about SVR is it doesn't matter because we are doing both. And Hy-Pro is best in class at the insoluble removal. And then the inverse is the dissolved side. EPT is best in class in that. So the SVR has brought together two best in industry products, and together they're incredible. When you operate with an SVR on your system, it doesn't really matter what the pressures, temperatures, or flows are. We are going to address both sides of the equation at the same time, and magic's going to happen as a consequence. When you address both sides of the equation with SVR, this is incredible. And inevitably, all the other solutions in the market are doing one side or the other and implementing not only a half a solution, but maybe a 0% solution, depending on what your operating temperatures are, okay?
One of the things I like to mention is we as a company can offer every solution that is talked about out there, and the SVR is the complete solution for what you were talking about. So can you go into a little bit of detail about the history on how the ICB, the resin beads, how your father got it started, and where it is today, because that's a very big part of the SVR performance.
Yeah, it's funny. Just to you go into a new country, and I never expected to travel 50 countries in the world talking about lubricant quality and chemistry management and optimization and oil testing. But that's what's happened, and this whole SVR started with a problem. There was a problem that was causing gas turbines to fail, and this is in 1990. It was causing 4 complete failures per year, costing $2 to $4 million per failure. Then the production losses were on top of that. And when my dad started investigating this, what he found out was that 100% of the maintenance budget was being spent not on the problem, and that the oil testing and oil maintenance was strictly focused on particulate removal. And while essential, the root cause of failure in this case was chemistry. But when you look at chemistry management across the industry with lubricants, no one except EPT and Hy-Pro are doing that. Everybody is basically at varying levels of failure, and you're trying to figure out when to change your oil before that failure happens, but it's really not something that you can safely predict. So, ion exchange resin technology, is from the water industry, right? So this is how water treatment plants work. To use this outside of that application was considered crazy, and we were told we were crazy by the inventors of ion exchange resins at Dow Chemical. So what's interesting is by applying an adapted solution from the water treatment industry into the oil application, now we have brought for the first time in history the ability to manage the chemical properties of lubricant in addition to the physical properties. So that was the magic and how it started. So many people will be surprised to learn that the last 1,000 SVRs that were made were based on a design of 100 that were installed on a fleet-wide basis in 1992. So while some people are looking at SVR as something new, its design has been in place since the early 90s. It's quite an exceptional case history.
Yep, that's really fascinating. That's a great history on how we got started and where we are now. Want to ask you both this as far as where we are with varnish and where the industries are going. Aaron, I'll start with you. Where do you see this? It seems like it's branching out more than just turbine oil and potentially other oils. It seems like more industries are starting to learn about it. But what's your thoughts on where this is going from here?
Well, it's varnish is not just a challenge for power generation, and I think this is something that we learned once we adopted the technology and started to partner with this with EPT and bringing it to the market. we began to encounter varnish in other places, paper mills, steel mills, injection molding, just to name a few. And I don't really even think that it's a new problem. It's just that people accepted it. We think of that maybe as maintenance mediocrity, where they just accepted it and said, well, this sludge or this deposit, it's just part of hydraulics and lubrication. And now that we have this solution for it, and we've got a great technical center laboratory to do analysis, and the compounding knowledge that we've gained together over the years has really prepared us to take it to many other applications. So, I think that it goes well beyond power generation, and even within power generation, not just dealing with varnish, but when we also discovered that this was a solution to restore steam turbine demulsibility. I mean, that's a real breakthrough. So, getting that to the market, it's just another extension of really what the ICB ion exchange technology can do.
Yeah, Aaron, just to follow up on that, we are at the point now where the chemistry of lubricants can be managed. And when I say that, that's not something that just happened. It's been a 30-year journey to get to the point where we can look after acid, we can look after varnish, we can look after demulsibility, we can look at rates of additive depletion. So it's really not a varnish solution. I mean, varnish is one of the side effects of managing the chemistry of your lubricant using SVR technology and ICB technology, but really, it's a step change forward. So lubricant chemistry management, your lubricants are either in a state where the chemistry is managed or the chemistry is completely unmanaged. So it's a different thinking. It's a different step. It's a different way of managing and looking after your lubricants.
Yes, and not just reacting to a problem, or not just reacting to a failure mode or something, but changing the mindset that my oil is an asset, and I'm going to maintain the chemistry of it at all times, is a real shift. And I like where we're going.
Yeah, I would just, on average, I would say the average user is getting about 20 to 30% of the potential life of their lubricants. But when you operate them in an unmanaged state on a permanent basis, their life cycle is extremely short. So by managing the chemistry of those properties, you can get that lubricant closer to 80 to 100% of its potential life.
Yes, I agree with that. I do think that varnish will become a more household name in conversation, where it's not an unknown name as it still is today to this extent, and it will branch out more than just turbinol or RNO oils. Let me ask you this, Peter. Whenever we have potential customers out there, people that are coming across varnish for the first time can be enticed by some of the other technologies that are out there and be misled. What would you recommend that they do first to make sure and do their due diligence?
It's sort of like getting a smart kid at class to do your homework. It's just not going to work, right? You might get away with it once or twice, but eventually you're going to get caught. And really, people need to go to first principles on this. And if users, individuals, when you want to solve a problem, go down to first principles, understand what is the problem. And people have skipped this step. And someone comes in their front door and offering them something that's shiny, some lights on it, and this is a solution to my problem. How do you know it's a solution to your problem if you don't even understand what your problem is? So there's a misfiring here and a misallocation of resources. Like really, 100% of the maintenance budget right now is likely not being spent on the root cause of failure, right? So, okay, understand the issue. Understand the issue's chemistry. What can I do to manage the chemistry properties of my lubricant? Does this product that I'm evaluating manage those? And as soon as you look at it that way, and in that light, everything is clear. And users are now empowered to make decisions that are going to be much more effective, and they're going to look good out of it. People don't want to make bad decisions and buy the wrong system, but without understanding what the cause is, the root cause of failure, what the root cause of failure is with the lubricant and the machine, then you become enlightened, and the solution is quite straightforward, actually. And just to go into the chemistry just for a moment here, the polarity of the material that's in these lubricants, the contaminants that are generated from oxidation, are really more attracted to the mechanical surfaces than the oil itself. You think about that. So SVR is really sacrificial surface area that you can put onto a system on a full-time basis, so that it's easier to change the filter out than a bearing or a servo valve. And we've advanced the technology to that point where we are essentially sacrificial surface area, donating surface area that preferentially attracts what you'd never want on your mechanical surface. Okay? And when you install it on that way, when you install SVR on a permanent basis on your system, it can't ever deposit on your mechanical surface. It's impossible. So this is sort of the step change in thinking and in terms of transitioning maintenance to a much more proactive role.
Okay, thank you, Peter. That was really good information. And to reiterate that we are the sacrificial component and take that responsibility away from the bearings or valves or other components in the system. Aaron, anything you'd like to add to that with somebody new entering the world of varnish, what you recommend they do first or focus on first before they get into solutions?
Well, I think the most important part is to focus on lubricant chemistry management. That starts with oil analysis. It starts with a baseline of where we are and making a condition-based decision, and really leaning into the education along the way. There have been, over the last 10 plus years, a lot of things tried to help improve the reliability of the turbine lube oil and specifically to address varnish. And, we've got a rich history of success in many oils, many applications. And so, but for me, it starts with the oil analysis, relying on the experts in the technical center, and then, take that step to implement the solution, and then really fulfill their responsibility to keep up with the oil analysis and partner with us as the expert, and we'll deliver the solution.
So Aaron, just to add to that, you introduced the topic of oil analysis, and I get a little hot under the collar on this topic because users are expecting something very different from what they're receiving. And just as a starting point, if you're starting out or trying to improve your program, is like, can you show documented compliance that you're in industry specification? And I know that sounds simple, but it's not. And I'm going to tell you right now that half of the industry, if not 75% of the industry, cannot document compliance with industry standards. And you think about that. That is unacceptable. You go into the oil analysis head first and you realize right away that the oil analysis packages that are being done right now are grossly insufficient. And to go so far, I would say, a diesel engine is very different than a gas turbine. Yet, why are they using similar oil analysis packages? And it's like the lowest common denominator. $60 is what I have to spend. What can you test for me for $60? It's like, well, not what you need tested. What needs to be tested is very clearly been published. And this is an industry standard, and it is also a specification. And my second rant here, this is turning into a little bit of a rant, is that you're doing oil analysis, yet the lab is very likely not following the test standard. And you ask yourself the question, how is that even possible? But that's what's happening. The varnish test is a 100-hour test. And if the longer the oil is in the sample bottle, the higher the MPC value will be. So for this reason, it has to be reset. But then now it takes 100 hours. So you reset it by heating it for it's 98F for 24 hours and aging it for 72 hours in a dark place. That's not an easy test for the lab to do now. But I'll tell you what, if you don't do that test, your results are meaningless. and you're going to chase false positives. You're going to deploy maintenance dollars on the wrong machine, and while you're doing that, you're going to miss deploying the resources on the machine that's most critical to your business that's out of spec. So as a starting point, make sure your testing is accurate. Make sure your testing is actually done to the standards. You're doing the right test at the right interval. And then you can say, oh, I'm either in specification or I'm not in specification. And that's the starting point to all maintenance programs. But I find that, how is it even possible that users aren't at that point? So I'll end with that.
Yeah, and just to add on, I think this is some of the frustration for the user community, to learn that I'm trying to understand the condition of my oil. I go to a lab and, can I trust that lab? Are the results correct? It's got to be incredibly frustrating. And, I love it when you get fired up about oil analysis, Peter, because it's the most important first step that is taken. And, the information is the most valuable thing in this process, being informed about what's actually happening in the turbine lube oil. It's like understanding what's happening in your blood. And, you wouldn't want to make a decision about your body if you didn't have the right information, maybe that second opinion. But, what we do know is that we operate under the standards in the laboratory, in the technical center, and the results are comprehensive and really beyond what anybody else is doing. So that, to me, the oil analysis is the most important first step.
Yeah, 100%. And the thing is, you're already spending the money. You're already doing it. It's just, let's take your data so that it's actually meaningful and will allow you to prioritize what needs to be done first. First of all, am I in specification? Yes or no? Once I'm out of specification, it's like, can I save the oil or do I clean the oil? This is just basic decision-making triage, like you would if you went to the doctor at the hospital. This is what they're going to do there. But we do the same thing with with customers' equipment. Let's get them in specification as quickly as possible and then move forward.
Okay, thanks, guys. I really appreciate the information. One thing I would like to add is every turbine is unique, just like every human, so every turbine needs to be tested, and we can help out with analyzing and breaking down the test results. So that's something that we do often, and we can help out with that. I would like to go back to lab reporting a little bit more. Peter, any comments on that? Anything about other aspects, data points, particle counts you'd like to comment on as far as the lab reports?
Yes, it starts with basic knowledge, and these ISO particle counts are arbitrary codes, classifications with ISO 4406, and really Hy-Pro's taught me everything I know about ISO 4406 and the test standards to particle filters. And it's another hot button topic with me because I'll have users of $200 million turbines ask me, Peter, can you just write down exactly what you said to me and put it in an email to my boss? And I was like, what do you mean? He says, well, my boss doesn't want to spend any money. And I said, what do you mean? You're 2,300% above maximum condemning limits or target values for ISO 4406. And he's like, yeah, just put that in writing and send it to my boss. So I send the email with the boss on there, and you know what happens. In less than a couple of minutes, the phone rings. He goes, what do you mean? I'm 2,300% above industry target in my gas turbine. I was like, well, you're using the wrong filters, sir. Unless you're using a high efficiency filter from a reputable company like Hy-Pro, again, it's just a step in the wrong direction. This is the most basic stuff. We can fix this. We can transform programs with DFE filters to make sure that, your particles per milliliter, we've seen just extraordinary results of what we can do from between before and after with the SVR, with DFE filtration.
Peter, that's a really good point as far as the solid particles and contamination control as well. Aaron, is there anything else you'd like to add before we wrap up this podcast?
I think understanding the the genesis of the DFE technology is worth a little bit of time. And just like with the ICB technology, DFE started with a problem. And initially we had some customers who would send servo valves into their manufacturer for warranty claim because they would fail. And they always came back with contamination-related failure. And somebody looking for a root cause to that said, why does this keep happening and what can we do about it? And so we took our test stand apart and changed it so that we could create a dynamic hydraulic environment to simulate what they were seeing in their system. And when we did that, we thought, wow, we didn't realize filter elements actually worked in this way when they're subjected to dynamic conditions. And we almost didn't believe it. So we took the test stand apart, put it back together, did the test again, same thing happened. So we said, okay, we got to rethink how we're designing these filters and the media and everything, the shape of the pleats, everything that we had in our control. And lo and behold, we came up with something that was performing different to what we'd seen in the market before. And the biggest leap for us was as soon as we felt like we had that, we got out of the lab and into the field with online diagnostic equipment, and we were able to verify that these DFE rated filters not only captured contaminant at a very high efficiency, but they also retained that contaminant at a very high efficiency. And that's really the difference. And then from there, we did start to see customers saying, hey, I sent my servo valve in and it came back and I got the warranty. It wasn't a contamination issue. So that was how DFE started. And I think in the true spirit of innovation, much like how EPT Clean Oil innovated, we weren't afraid necessarily of what we didn't know, and we didn't see that as a limitation. So taking strategic risk with innovation while understanding our limitations and understanding and having respect for those limitations and taking risk, I think is how we've advanced both of these technologies to the world-class solutions that they are.
Well, I found that there's just very few companies that are curious on why things are the way they are, and it's only through your innovation development program and your testing program that you discover this. I never intended to be in the oil analysis business, but we had to set up our own lab for research purposes, because if we're trying to improve, say, the electrical properties of something by 5 or 10%, meaning the accuracy of the commercial oil analysis lab is far greater than that, you can't even tell if you've made a step forward or backwards. So it's this, you said something really, really clever there, and it's like it's not a fear to fail, it's I need to discover, I need to understand what I don't know, and it's that acceptance that there's things out there we don't know, and it's the discovery process of learning those things that really drives innovation at organizations. So well said.
Okay, thank you for listening today. Stay tuned for future episodes of Hy-Pro's Factory Side Chat. Thank you, Peter Dufresne and EPT, for being a part of this Factory Side Chat today. It was really fun. Be sure to follow both Hy-Pro and EPT Clean Oil on our social media channels, including LinkedIn and YouTube. Thank you very much.